All right, we're going to begin. So let's look at logarithm of numbers. We're going to start with logarithm of numbers greater than 1. All right, basically the base 10 logarithm of a number is the power to which 10 is raised to give that number. All right, so basically the logarithm of a number is the power to which 10 is raised to give that number. For instance, let's look at logarithm of, look at this number, logarithm of 374.5 to base 10. You could be asked to find the logarithm of this number. Alright, so the logarithm of this number is the power to which 10 is raised. That's what it means. So we're going to say the logarithm of this number is, we're going to break it down like this. So break it down. First of all, write it in standard form. This is 3.745 times 10 to the power of 2. Remember, standard form, the first number is between 1 and 10. Must be a number between 1 and 10. And then 10 is taken to the power. Now the power of 10 is 2. So take note of that. Then 10. Now we're going to use, so the power, what is the logarithm of 3.745 is the power to which 10 is raised. So how did they get this 0.5735? So I'm going to check 37 under 4 difference 5 using log tables. So we're going to check 37 under 4 difference 5. I'll come to my log tables, usually find at the back of your textbook. Logarithm of numbers, you see that logarithm of numbers. So I'm going to check 37 under 4 difference 5 because see, the numbers are starting from 10 to 2 digits. So let's go to 37. 37 is somewhere there under 4. 37 under 4. See, I have numbers under 0, under 1, under 2, under 3. So under 4, I'm going to trace it down to 37. 37 is there. 5729, difference of 4. 5729, store that up. Then difference of 4. All right, so we're going to add the difference. 37 under 4. We're going to add to 4. All right, just to recap, we're looking at finding we said that the logarithm of 3.745 right there, the logarithm of 3.745 is the power to which 10 is raised. This is 10 power 0.5735. You ask yourself, where did they get 0.5735? We are using log tables. Remember, before the advent of calculators, it was logarithm tables that we are used to manipulate numbers. We're going to go to logarithm tables and look for 37 under 4 difference 5. All right. My logarithm table over here, it's my logarithm of numbers. I'll go to 37. See 37. This is our column for your first two numbers, 37. So I have 37 there. Then under 4, see we have column 0, under 0, under 1, under 2, under 3, under 4, under 5. So under 4, I'll use my ruler to trace that. 37. That's 37 there. 37 under 4. See, under 4, we have 5729 right there. 37 under 4, 5729. Then, a difference 5. The last number will be the difference. So the last number is 5. So we're going to trace difference 5. That's 5729. 37 under column 4. Difference 5. See, differences under 5. That is under 5. Differences, you have number 6, right? So that is 6 right there. We're going to add 6 to 5729. 5729 plus 6 will give us 5735. And so that is how they got 5735. All right, that's how they got 5735. Now this is 0, then times 2. So use your law of indices. Remember, law of indices, when the bases are the same, base 10, you simply add the powers. 2 plus 0.5735 will give you 2.5735. This is the final answer for the logarithm of 374.5. That is 2.5735. All right, so this is it. Log 374.5 base 10. Take notes. Our logarithm tables is taken to particular base 10. This is known as common log. All right, because there are other bases that you can find the logarithm of a number to, but the common base is base 10. So the common log of 374.5 is 2.5735. All right, it's pronounced as the logarithm to base 10 of 374.5 is 2.5735. I have explained that. This is logarithm. All right, see, look at it here. The power. Remember, we said that that's what's the logarithm. Logarithm of a number is the power to which 10 is raised to give that number. Look at it. The logarithm of 374.5 is the power to which 10 is raised. So see, the 10 is raised to the power 2.5735. This is the logarithm of that. This logarithm number can be described. The integer part is called the characteristic, and the decimal part is called the mantissa. All right, and this characteristic is usually gotten by writing the original number in standard form. Remember your standard form. The first number must be a number between 1 and 10, because look at this number is not between 1 and 10. We tend to rewrite it, put the first, break it down into number between 1 and 10, and then a power of 10. So this power of 10 always gives us our integer, which is called the characteristic. 2 is a characteristic. All right, we're going to look at some examples on that. How are they now used for complex calculation or harder calculations like that? We're going to look at how do we calculate 76.7 times 308.2 divided by 8.04. All right, take it one by one. We find the logarithm of this, then the logarithm of this over the logarithm of this. Remember, multiplication becomes addition, division becomes subtraction in indices. All right, so let's look at how this was done. Of course, without calculators. Now, 76.7 times this. Now remember that multiplication becomes addition because we are dealing with the powers. We add the powers. So multiplication becomes addition, and then division, because this is a dividing line, this division becomes subtraction. Remember your law of indices. All right, 76.7. So we're going to find the log. So to find the log of 76.7, it's simply going to be 76 under 7. Remember, if you write this in standard form, it's going to be 1 point. Yes, if you write 76.7 in standard form, 76.7 is equals to, this goes here, decimal point, to have 7.67 times 10 to the power 1. This power become our characteristic. Whatever we get will be 1 point, whatever we get from the log table for this. 1 point, we're going to check 76 under 7. 76 under 7 from my log table here. 76 under 7, this is 76 here, 76 under 7. That's 76 right there, 76. Under 7, I'm going to use my ruler to check that out. 76 under 7, 76 under 7, 76 under 7. So under 7, look at 7 right there, 7. So under 7, 76 there is, you have to agree, is 8848. So 8848, I'm going to write that down. 8848, 8848, 8848. 76. So there's no other value here, so there's no difference. So it's going to be 8848. So that's how they got 1.8848. Similarly, 308.2. First of all, let's get the characteristic. That is the integer part. Standard form, this goes 1, 2. So it's 3.082 times 10 to the power 2. So 2 is going to be the integer part, also known as the characteristic. So that's 2. See that? We are dealing with this second number here. We've gotten that the characteristic, that's the integer part. When you write this number in standard form, the power on 10 is 2, so that gives us the integer part. Then how do we get this decimal part? It is going to be, from your log table, check 30 under 8 difference 2. So I'll go to my log tables. All right, so that is logarithm of numbers. See there's written logarithm of numbers. 30, there's 30, 30. All right, under 8, so 30 under 8 is 4886. That's 30 under column 8 is 4886. Difference of 2. Look at my differences. Differences is 2. So this under 2 we have 3. We add your differences. I'm going to add 3 to 4886. And you have to agree that's going to be 4889. That's how they got what? 4889. That's how they got the what we call the decimal part. The decimal part, or the mantissa, is gotten from the table, while the integer is, or characteristic, is gotten from writing this number in standard form. Remember that these are now powers of 10. So the power to which 10 is raised is this. The logarithm of this number is the power to which 10 is raised. This is equal to 10 to the power of 1.8848, and this is equals to 10 to the power of 2.4889. Now remember, powers are added. They have the same base 10, so you add them. So 8 plus 9 is 17, 7 carry 1. Add that is 13, 3 carry 1. 17, 7 carry 1. 13 carry 1. So this is 4.37. Now, how do you go from log back to number? Because this is the answer. By the way, we have to deal with the denominator here, 8.04. So 8.04 has to be changed to logarithm. And this is already in standard form. So the power on 8.04. So if I go 8.04 in standard form, you have to agree it's already in standard form. So the power on 10 is 0. Alright, so 0 is going to be our integer. Alright, so just to recap, we are using log tables to calculate this expression. 76.7 times this. What we have on the numerator, we've gotten it as logarithm 4.3737. Now the denominator 8.04, we have to treat it also turn it to logarithm. The logarithm of this is this. That's basically the power to which 10 is raised. The integer part is 0 because this number is already in standard form. I showed us. Now, how do we get the mantissa or decimal part? We use log table. So I'm going to check 80 under 4. I'm going to check 80 under 4. I'm going to go to my log tables. But this is my logarithm of numbers. So I'm going to go check 80 under 4. That's 80 is here. That's 80. 80 is right there under 4. Remember? These are under 0, under 1, under 2, under 4. So it's 80. Let me use my ruler to line that up. That's 80 under 4. 80. That's 80. 80. So 80 under 4, you have to agree with me that it is that 9053. 9053. 80 under 4. There's no other number. This is just what we're going to use. 80 under 4 is 9053. And so that's how they got 9053. Now, this is division. Division becomes subtraction for powers. All right. So we have to subtract. When you're dealing with indices, remember division becomes subtraction. All right, because they have the same base. So subtract. So let's do our subtraction from what is on top. What is on top simplifies as this, and what is under simplifies as this. So let's subtract this. 7 minus 3 is 4. 3 minus 5 not possible. Borrow gives you 13 minus 5, 8. We're left with 6 here. And they borrow again to get 13 minus 9. Alright, this is what we have so far. Basically, what we're looking at is this. This is what? So this is 76.7 is 10 to the power of this. Times 308.2 is 10 to the power of 2.4889. Divided by 8.04. That's divided by 10 to the power of 0.9053. Now, in law of indices, when they have the same power, basis, base 10, base 10, base 10, you simply add multiplication. Multiplication becomes adding just the powers up there, and then division becomes subtraction. But by the time you do this plus this minus this, you get 3.4684. What we're left with now is how do we move from this into back to the number form? Because how do we move 3.4684 back to its number form? We use anti-log tables. So we're going to use anti-log tables to move from 3.4684 back to the number form, because this is the logarithm form and this is the number form. We need our answers as number form, all right, not as powers of 10. Now, so what we're going to do is you leave the integer out of it, like doing anti-log. Anti-log is a reverse process of logarithm. So just check your decimal fraction, the decimal part. So we're going to do 0.46 under 8 difference 4 using anti-log tables. So I'll go to my anti-log table, anti-log tables. So you have the anti-logarithm of numbers. So it's 0.46. We're checking 0.46 under 8 difference 4. 0.46 is right down there. That's it. 0.46 under 8. Let me line up my ruler. 0.46 under 8. Yes, 0.46 under 8. That's under 8 there. That's under 8. Trace it down. That's 8. Trace it down. 46 under 8. That's 2938. Difference of 4. 2938. I'm going to difference of 4. This is my differences column. Differences column. Difference 4. Trace it down. Difference 4 is giving me 3. So I'm going to add 3. Always add your differences. I'm going to add 3 to 2938. 2938 plus 3, my difference. 2938, that's it. Plus 3 is going to give me 294. Alright, we've checked that. We've added. Let me do that again. So we got the anti-log. We're using 0.46 under 8 difference 4. We're checking out 0.46 under 8 difference 4 on the anti-log table. And we got 2938. That's 2938. That's there. 0.2938, and we're adding the difference 3. We get 2938 plus 3. We give you 2941. Of course, 2941. So that's how they got 2941. 2941. All right. Now, how do we deal? It remains now this integer part. What do we do to this integer part? The integer part, you add 1. Always add 1 to the integer. Remember, it decreases Numbers, it decreases going to the right, it increases going to the left. With practice, we understand. So this 3, add 1 to it. 2941. How do we treat 2941? How do we treat there's a part for the decimal point. So this 3, add 1, it will inform where we're going to put our decimal here. So 2941 will count 1, 2, 3, 4. Put your decimal points after the 4th digit. This is what I mean. Look at. Remember, we didn't touch this integer part. We only looked at the decimal point, the decimal part. Sorry, 0.46 under 8 difference 4 in the anti-log tables, and we got 2941. Now this integer part, what do we do with it? You add 1 to the integer. So always add 1 to the integer. In this case, it's 3 plus 1, 4. So you now count. Let me do the rough work here. You count. You count 4 digits, 1, 2, 3, 4, and add your points. And you can just add 0. This is the final answer. And you can always check. You can always check with the calculator to see if you are close to the answer. This is how calculation was done before calculators were invented, using our log tables. All right, using our logarithm tables. All right. So just to recap, to go from numbers to logarithm, we use logarithm tables, and to go from logarithm back to numbers, we use anti-logarithm tables. Taking note, the special ways we deal with the integer part. All right. So remember this this integer 3. We always add 1 to whatever. If it was 2, to add 1 and to become 3, and we'll count 3 digits, 2, 9, 4, and put our points just between 4 and 1. But because it's 3, we add 1 to 3, becomes 4. So we count 4 digits starting from the left. 1, 2, 3, 4.